So this video lesson is all about angle pairs, and before we get to talking about what angle pairs are, we have to go back and look at some important vocabulary related not only to angles, but to geometry in general. So in the very basic sense of geometry, we have four things. We have a point, we have a ray, we have a line, and we have a plane. Now each of these is related to the other in some way, but they all are a little bit different. And so we have a point, which is just this one location in space. We have a ray, which is an extension of a point in one direction for infinitely long. A line extends two ways forever and ever and ever, so it just continues going and never ends. So even though the line itself on the paper, or at least on the video that you're looking at, ends at the end of the arrow, we actually imagine that this continues and continues and continues and would continue forever. And a plane, a bit difficult to say on a video or on paper what a plane is, but it's just a flat surface. So the screen of the computer or the screen of the slide that you're looking at right now is a plane. It is a flat surface, has length, has width, and when we talk about a plane, we imagine that one goes on forever. So in technical definitions for point, rays, lines, and planes, first, a plane is a flat surface that extends forever in all directions. Again, if you imagine this computer screen extending forever in all directions, up, down, left, right, or if it's flat on a surface, then in all directions so that it covers everything as a flat surface, that is a plane. The point is a single specific location on a plane. A ray extends forever in one direction from a point, and a line extends forever in both directions. Technically also from some generating point here, but it extends forever in all directions, so we just draw it as a line like that with arrows at the end. The arrows signifying that it does continue forever. So from these, we eventually build into the definition of what an angle is. And an angle happens when you have two rays that intersect at one point on the plane. And so the angle is not only formed by these two rays, it is the space between the two rays. So not just the rays itself, but it includes all of this space in here. So an angle is in the space between two rays. Two rays stop at a certain point. Where they intersect, now if they're lines, they continue. But where they intersect is called the vertex. It's not called a point because that would be confusing when you're talking about a place on a plane being a point, because we have a point over here. But you're talking about the place where they intersect, and so we call it the vertex. And finally, an angle is measured in degrees. When we talk about an angle having degrees, the degrees refer to how much space is between the two rays. The more degrees, the more space. And this brings us to a definition of an angle that is very important and you may not have heard before. An angle is also what you get when you rotate a ray. So we have a ray right now that's sitting more or less horizontally, extends from this vertex onward over to this location in space here, to this point. Now, what we mean when we rotate a ray is if we took this ray and moved it, say, to here. We have the ray down at the bottom where we started, and now we've moved this ray this far around in a circle. This is also what an angle is. An angle is what you get when you rotate this ray. It is this change in space. Now, no matter how much space is actually in here and how large these purple arrows are, they still has the same number of degrees because the degrees tells you how far around the circle you've rotated. And again, that underscores the fact that the angles are not just formed by the rays, but it encompasses the space between the two rays also. So I'm going to show you a picture that has a lot of colors and a lot of rays and a lot of line segments and a lot of lines. But I want you to try to pick out some angles, not only that are formed, obviously, in this picture, but are included in the intersection of some lines. So take a look at this picture and see if you can identify three different angles. Now, obviously, there's some angles that are pretty easy to see. In the red square, we have the angle up in the upper right-hand corner. That is an angle made by the red square. In the yellow square coming up here, we have this angle made by the corner. We have this angle in the bottom right corner made by the green line. Let's take this but we also have some other things. If we look at, say, let's make this line an obvious color here. If we follow, say, this yellow line, you're starting right here. If we follow this yellow line up to this point where it intersects with the other yellow line, this is an angle also. This is an angle also. So we have lots of different things that could be used as angles. An angle is just two lines that are intersecting, and or two rays that are intersecting, and the space between. Let's see if we can make this a bit more obvious. I'm going to shade this down a little bit so you can see where I drew the angles. So now that it's shaded down here a little bit, you can see more obviously where the angles are. All of those are examples of angles. So now let's take a look at a few special types of angles. And so that's it for the review. We're going to look at a few special types of angles, and right now we're going to look at this picture here of a floor. And this floor has some lines in it. And so if we choose one point where lines intersect, which is here, if we start there, we look at this angle, and we can see that we can follow the line through the point there. And a straight line actually forms what's called a straight angle. This angle is said to have 180 degrees. 180 degrees because it is flat. And so the angle not only is that, but it is the rotation that goes from one end of that ray to the other. On the other hand, we can go down one line and turn directly onto the other line. Now this creates what's called a right angle, which has a 90-degree angle, which is also sometimes called a square corner, because a square has all right angles. So a right angle is 90 degrees, a straight angle is 180 degrees, and if we think about them as rotations, a straight angle is a half of a full turn, so you're facing one way and you turn to face the other way, directly opposite from where you were facing before, and a 90-degree angle starts facing one way and you turn a quarter of the way around. So these are called straight angles and right angles. And finally, using straight angles and right angles, we can talk about some special relationships between angles. As a review, take a look at the red line here. What kind of angle are we forming here? If you answered straight angle, that is correct, because this is a straight line. Well, if we look, we have some other lines that are intersecting with this line segment here, such as that one. And that forms two new angles. We still have the straight angle on, say, the top of this one. But if we look at the bottom now, our straight angle has been cut into two segments, angle 1 and angle 2. Now, collectively, if we added these two angles together, or combine them, they would have to be equal to a straight angle. Their measures, which is the number of degrees in the angle, have to equal 180 degrees. And they form a special pair of angles called supplementary angles. These angles are angles whose measures add up to 180 degrees. So the red line here is a straight angle. And we can see that angle 1 plus angle 2 has to be equal to a straight angle, because they're formed just by drawing a line segment in between them. So we write that by saying the measure of angle 1, and we use an M with this angle symbol and 1. Be careful that it is not a less than symbol. That is not an angle symbol. The angle symbol has one flat line, one horizontal line, and the angle there. So the measure of angle 1, however many degrees this is, plus the measure of angle 2, has got to be the measure of a straight angle, which is 180 degrees. Now we can do the same thing with this type of angle. What kind of angle is this? If you said right angle, you are correct. It is an angle of 180 degrees, and we have multiple lines now that are coming into the vertex of this angle. But let's look at this line here. cutting halfway through the right angle. That also splits our right angle now into two angles, angle 1 and angle 2. Now, just like the straight angle that we talked about, these two angles must add up to be the 90 degrees that is in the right angle. All we did was draw a line in the middle and split that 90 degrees into two different segments. So that means that the measures of these two angles must add up to be 90, because that is the number of degrees in a right angle. These angles are called complementary. Angles that add up to be 180 degrees are called supplementary. Angles that add up to be 90 degrees are called complementary. And we write that by saying that the measure of angle 1 plus the measure of angle 2 must equal 90 degrees, which is the measure of a right angle. So take a second using those definitions. Complementary is adding up to 90, and supplementary is adding up to 180, and see what you can do with these angles here. Find a complementary angle for angle 1 as 24 degrees, 48.5 degrees, or 45 degrees. And find supplementary angles for an angle that is 45 degrees, 127 degrees, and 179.5 degrees. Well, starting with the complementary angles, we know that for each of these angles, something plus that number has to equal 90. So 24 plus some unknown angle has got to equal 90. If we take 24 away from 90, we have that the measure of angle x has to equal 66 degrees. For the second one here, 48.5 plus some unknown angle is also equal to 90. Subtract 48.5 from both sides, if we're solving this like an equation, like it is, and we get that the measure of the unknown angle has to equal, well, 48.5 plus 41.5 is equal to 90. So this measure of this angle has to equal 41.5 degrees. And finally, for measure 1 is 45, the angle that you're looking for is also 45 degrees. Now, taking the same idea with supplementary angles, this angle plus something has got to equal 180. Subtract 45 from both sides, you get x is equal to 135 degrees. The supplementary angle for 127 is 53 degrees. And the supplementary angle for 179.5 is 0.5 degrees. And so there's one last concept that we have to talk about, and that's what we have when we have long intersecting lines. So this is the view down from a bridge onto Lake Michigan and to the underlying support structure, and we have two lines that cross each other like that, and they've now been highlighted in red. Well, these two lines create four angles: angle 1, angle 2, angle 3, and angle 4. Now, some of these angles share a line segment, like angle 1 and angle 4 share the one I'm shading in green. Angle 2 and angle 3 share the one I'm shading in blue, but angles like angle 1 and angle 3 don't share any. There is nothing in common between them. We call these kinds of angles vertical angles, angles that are made by intersecting lines and do not share a ray, or yes, they do not share a ray. The point moving from the vertex of the intersecting lines away. So angles 1 and 3 don't share a ray. Angles 2 and 4 don't share a ray. So 1 and 3 are vertical angles, and 2 and 4 are vertical angles. And the other great thing about vertical angles is that they always have the same measure. Always. So whatever angle 1 is for degrees, that is what angle 3 is. And you can see vertical angles in a whole bunch of different places, like the supports of a bridge, or when a skier crosses their skis when they're up on a jump, or wherever they are. That also creates vertical angles. So go ahead and look at these four problems using complementary, supplementary angles, and see what you can do in terms of finding out what the degrees of these angles are. So while this may seem like a lot of things to work on, it's actually not that many. We can do them all in terms of what we have learned before. So we know if angle 4 is equal to 65 degrees in number 1, that angle 2 must also be equal to 65 degrees. And finally, what we can see is that angle 1 and 2 form a supplementary pair. So we have the measure of angle 1 plus the measure of angle 2 must equal 180 degrees. And since angle 1 and angle 2 have to add up to 180 degrees, angle 1 has to be 115. degrees, which means angle 3 as a vertical angle must be 115 degrees. For number 2, angle 1 is a right angle, which means it's 90 degrees. Means that angle 3 is 90 degrees because they are vertical angles and their measures are the same. And since angle 1 and angle 4 form a supplementary pair, they must equal 180 because they form the two halves of a straight angle. Angle 4 must also equal 90 degrees. And so angle 2 must also equal 90 degrees. Now 3 and 4 are a little bit more difficult, but not too bad once you think about them. Angle 1 is equal to 30 degrees. That means that together angle 2 and angle 3 have to equal 60 because these form a complementary pair where angle 1 plus angle 2 plus whatever's left has to equal 90. And if angle 2 and angle 3 are the same, they must have the same measures that add up to 60 degrees. And so half of 60 is 30, so angle 2 and angle 3 are also both equal to 30. And finally for number 4, angle 1 is a right angle, which is 90. Angle 4 is equal to 25 degrees, and so looking at the vertical angles that are made with angle 4 and angle 3 by the crossing of the two blue lines, which is why I highlighted them in blue. If angle 4 is 25, angle 3 must also be 25. And if that's true, angle 2 and angle 3 have to add up to 90 degrees because they are complementary angles, and the complementary angle to 25 degrees is 65. So as a quick review of the new terminology so far in this lesson, we have that a straight angle is an angle that is made of 180 degrees, where a right angle is an angle of 90 degrees. Two angles that add up to a straight angle are called supplementary angles. Two angles that add up to a right angle are called complementary angles. And when we cross two lines, we get what are called vertical angles, the ones that do not share a ray, that are across from each other, and also have the same measure.